where there's a hydrogen here, then that interaction is very small, so you don't expect very good selectivity. So no 1, 3.
Is it the rotation of this thing to get the hydrogen to correct position and do the substitution? This side is big, this side is small, so some stuff will come from the rear face.
Because this is hydrogen, there's very little difference between this conformation and, say, the metal down here. So if the metal group comes down here, the phenyl group will be behind and you get reaction from the front. So you get reaction from the back and the front, and so the full selectivity. But another case would be, say, where there's a metal group there. Now you're comparing that. Now there's very good stereo control because that interaction is greater.
Yeah, so that means if it's good, that means this will be the product.
Well, reaction from behind.
Yeah, will be the product. Okay, because I got a bit confused, like because when we have the cyclic transition state, then you say that if there's like interaction, then it is not favorable. Yeah, those that you draw.
Yeah, no, that's right. What we're looking at is different energies. So you have this.
How to get the least energetic interaction.
Yeah. You also have one with the methyl group there, and if that happens, then you have a hydrogen and a phenyl.
Yeah.
And then you also have one with a phenyl group.
Which is
in that case, if this is metal, hydrogen behind. So they're all in equilibrium. But these are about the same in energy. This is big enough that probably it starts to interfere there. So this is not very favorable. But this is just close, and then this is further apart.
This is the best.
so
Yeah, this is the best, and this is next best, but the energy difference is very similar. There's almost no difference in the energy between those two.
okay, so that's why like between these two, which one is preferred for interaction will be this one.
No. This is still preferred, but there's not very much difference in the energy there, so you get both. So this is the small group, so you get reaction from behind. This is the small group, so you get reaction in front. So if these have about the same energies, then there will be almost an equal population of those. So half the reaction will occur from behind, half will occur from front, and so there is no selectivity. What you're looking for is more reaction from one face than the other. It doesn't matter whether it's from behind or in front. So that's with the hydrogen here. Once you have a methyl group, then as you go along this series, this becomes much higher in energy than this conformation. And so now there is a lot of selectivity towards this one, and this is the one that will give you reaction from behind. And so now you get more of the isomer where you get reaction from behind. So with a substituent here, then you get good selectivity. Without a substituent there is very poor or no selectivity. When you got a substituent, and in both of these cases, there's no substituent here. So there's no composition from 1, 2.
Okay, then let's see if there's composition from 1, 2.
Yeah, so if you've got a case with a substituent there, then there are two other situations. You can have metal, and you also can have that situation. Now, next to this, you also have to have a conformation where the normal hydrogen there, if that swings up, the methyl group is in front, and the phenyl group is from behind. In this case, the same thing. have the same molecule but rotating around here. This is the preferred conformation from 1,3.
Oh, yeah, because this is small.
And this is the preferred conformation from 1,2. Now, in this case, there's very little difference between this and this. So if this happens, this will direct from the front face. This is from behind. This is from the front. You get reaction from the front of it. So this is a case where you'll get equal reaction from front and back through 1,3. So in other words, there's no selectivity. But this is much preferred over this because here there's minimal interaction. Here there is a lot of interaction between both of these groups. So this is preferred. And in this case, the small group is in front, so you get reaction from the front face. In the 1,2 selective case. So this will give you good 1,2 selectivity. In this case, again, this will direct to the front face, but here there is good selectivity for this reacting from behind.
Because these two are like away and this.
That's right. In this
From
case,
behind.
In this case, there was no 1,3 selectivity. We're getting equal reaction front and back. So we can more or less ignore that because it's going to give reaction from the front and the back. What this is then saying is that this will direct to the front. And so this overall will give you good selectivity, but it's controlled by the 1,2 selectivity.
Isn't this is controlled by 1,2 more than this one? Nope.
No. Well, this is another conformation, but it's not one of the extreme ones. This is preferred conformation. It gives you minimum energy, minimum interaction between these two. This will give you maximum interaction between these two. But in this arrangement, you can have this or this.
A mixture whether it can react in front or behind, so it's not.
No, but this is bigger, so they're more behind, I think.
Yes, but this can also be another conformation, and that gives you reaction in front. So there's an equal mixture. So this is not controlling anything. But if you also have this, then you will get selectivity, but it's controlled by 1,2, Allyic strain, not 1,3. Now in this case, this is trying to direct to the back. Okay. This is trying to direct to the front.
Okay. Regarding whether it directs on the front or the back, it depends on this and that.
This is the model we use for 1,2. This is the model we use for 1,3. What we're saying here, there is good selectivity through 1,3, but it'll be to the back. There's good selectivity from 1,2, but it will be to the front. So overall, there's poor selectivity because your 1,2 and your 1,3 are competing with one another. So these give good selectivity in both cases. For that reason, you get a mixture. This is giving you good selectivity through 1,2, but because the 1,3 selectivity is very, very poor.
So it refers to here.
Yeah. And if you have no substituent there, then the substituent will give you good 1,3 selectivity, and there's no 1,2 selectivity.
So to conclude this thing is, this is not significant and doesn't matter. But what's happened? And for this one, it's more selective, and this is preferred. This one has no. What is this one? What is this one?
This one gives you good 1,3
selectivity and prefer 1,3 behind.
But it gives you good 1,2 selectivity from the front.
Yeah.
So
Just one moment.